So we say the results of an experiment are called statistically significant if they are unlikely to occur by random chance. That is, if it is unlikely that the results are due to the possible imbalances created by the random assignment. Okay, so this is an important concept that we will use going forward. It means, okay, if the results of our experiments are unlikely to occur by random chance, then we say that those results are statistically significant. And the blank refers to the type of inferences or conclusions that can be drawn. This is called the scope of inference. The types of inferences we can make, inferences about the population and inferences about cause and effect, are determined by two factors in the design of the study. Okay, so those two factors are, were individuals randomly selected from a population, and were individuals randomly assigned to groups? Okay, so if they were randomly selected from a population, then we can make inferences about that population. And if they were randomly assigned, we've got yes, yes here, then we can make inferences about cause and effect. If they were not randomly selected from a population, then this would be no. We cannot make inferences about that population. However, if they were randomly assigned, we can make inferences about cause and effect. And there's a little note here. It said most or many experiments are in this category. And I think a lot of times in experiments, they are not randomly selected from a population because researchers are targeting a specific group that they want to study. So, for example, if they are trying out a new drug to help with high cholesterol, for example, then they want to look at people that have high cholesterol, right? That makes sense. And so a lot of times you will see advertisements about people that want to participate in a study, and the researchers are looking for people to participate in certain studies, okay? They're not just randomly selecting from a population because they're looking specifically for people that have a vested interest in the results of the experiment, okay? So a lot of times experiments come from this category right here. Okay, inferences about the population. If this is no, sorry, said that wrong. This is yes. But inferences about cause and effect are no. All right, there's some observational studies that are included in this category, and then the no. Not randomly selected, not randomly assigned, which we'll look at an example of that in just a second. Some observational studies fall into that category. Okay, well-designed experiments randomly assign individuals to treatment groups. However, most experiments don't select experimental units at random from the larger population. That limits such experiments to inference about merely cause and effect. Observational studies don't randomly assign individuals to group, which rules out inference about cause and effect. An observational study that uses random sampling can make an inference about the population. So we are going to look at a few examples. Many students, mine included, insist that they study better when listening to music. A teacher doubts this claim and suspects that listening to music is actually hurts academic performance. So here are 4 possible study designs to address this question at your school. In each case, the response variable will be the student's GPA at the end of the semester. Okay, so number 1. Get all students in your AP Stats class to participate in a study. Ask them whether or not they study with music on, and then divide them into 2 groups based on their answer to this question. Okay, so for each design, suppose that the mean GPA for students who listen to music while studying was significantly lower than the mean GPA of students who didn't listen to music while studying. What can we conclude? Okay, in the first one, was there random selection? Did I randomly choose from a population? No. So, with no random selection, I just took my AP Stat students, right? The results should be applied only to the AP students in the study. Okay. Was there random assignments? Did it say anything about randomly assigning some to listen to music and the others? No. Okay, so there was no random assignment either. So no conclusions about cause and effect because there was no random assignment either. Okay, scenario number 2. It says, select a random sample of students from your school to participate in a study. Ask them whether or not they study with music on and divide them into 2 groups based on their answer to this question. So here we have random selection. So with random selection, we randomly selected from our school population. With random selection, the results can be applied to the population. And what is the population in this case? Okay, it's all the students at school. All students at school. However, again, no conclusions about cause and effect because the treatments were not randomly assigned. No conclusions about cause and effect because no random assignment. Number 3. It says, get all the students in your AP Stats class to participate in a study. Randomly assign half of the students to listen to music while studying for the entire semester, and have the remaining half abstain from listening to music while studying. So in this one, we have no random selection. We just took the AP Stats students, so no random selection. So results applied only to the AP students in the study. Okay. With random assignment, we can. With random assignment, we can conclude cause and effect, but only for the students who took part in the study. And the study. Okay, and so in the last one, we're going to have both random selection and random assignment. It says select a random sample of students from your school to participate in a study. Randomly assign half the students to listen to music while studying for the entire semester, and have the remaining half abstain from listening to music while studying. So in this one, we have both random selection and random assignments. So results can be applied to the population, which is all students at school. And we can conclude cause and effect. Cause and effect, let's say a cause and effect relationship. So now we're going to talk about some challenges of establishing causation. A well-designed experiment tells us that changes in the explanatory variable cause changes in the response variable. More precisely, it tells us that this happened for specific individuals in the specific environment of this specific experiment. However, a serious threat is that the treatments, the subjects, or the environment of our experiment may not be realistic. And this lack of realism can limit our ability to apply the conclusions of an experiment to the settings of greatest interest. So let me see if I can illustrate this for you. How many of you work some type of job? So let me ask you a question. Just think about the answer. Do you perhaps behave differently if your boss is present than if your boss is not present? Let me put it on me. Let's say that my boss walks into the classroom. Would I behave differently? Hopefully not too much, right? But maybe. It's human nature. So if people know that they are being studied, and that's the case for the most part, if we're conducting an experiment, right? If people know that they are being studied, they tend to behave differently. And so that's not really the same as looking at something out in the quote real world. Does that make sense? And so one of the challenges for conducting an experiment is establishing a realistic setting or environment. In some cases, it isn't practical or even ethical to do an experiment. Consider these important questions. Does texting while driving increase the risk of having an accident? Does going to church regularly help people live longer? Does smoking cause lung cancer? So how about we do this? Those of you that drive, how about I randomly assign half of you to text constantly for the next 2 months while you're driving, and the other half not to text, leave your phone in the trunk, and we'll see who has the most accidents at the end of those 2 months. Well, what about this? How about I randomly pick half of you to smoke 2 packs a day of cigarettes for the next 2 years? Now let's do 10. For the next 10 years, you're going to smoke 2 packs a day. And the other half will not smoke. And then we'll compare those results at the end of 10 years and see who has more lung cancer. Are we in? All in? No. Well, obviously, that is not ethical. So to answer these cause and effect questions, we just need to perform what is called a randomized comparative experiment. However, unfortunately, we can't randomly assign people to text while driving or to attend church or to smoke cigarettes. So the best data we have about these and many other cause and effect questions come from, where do they come from? They come from observational studies. Okay, there have been in history, and we're not going to go into this, but if it's something that you are interested in, you can do a little research. But there have been times in the past where within certain situations, the Nazis during World War II, other times even in this country, where unethical experiments were conducted. Okay? Terrible, horrible things were done to people without their consent, sometimes without their knowledge. Okay? And that is completely and totally unethical. So there are parameters to experiments. It is sometimes possible to build a strong case for causation in the absence of experiments. For example, the evidence that smoking causes lung cancer is about as strong as, and we call this non-experimental. The evidence that smoking causes lung cancer is about as strong as non-experimental evidence can be. So what are the criteria for establishing causation when we can't do an experiment? Well, number one, the association is strong. And indeed, the association between smoking and lung cancer is very strong. That's one thing. The second thing, the association is consistent. So many different studies of many different kinds of people in many different countries link smoking to lung cancer. That reduces the chance that some other variable specific to one group or specific to one study explains that association. So in other words, is it just one study conducted in a certain place? Or do all of these studies around the world, looking at many different types of people in many different environments with many different types of factors, reach the same conclusion? Okay. Another one is that larger values of the explanatory variable are associated with stronger responses. So people who smoke more cigarettes per day or who smoke over a longer period get lung cancer more often. People who stop smoking reduce their risk. And here also the alleged cause precedes the affected time. So lung cancer develops after years of smoking. The number of men dying of lung cancer rose as smoking became more common, with a lag of about 30 years. So the last thing here is that the alleged cause is also plausible. Experiments with animals show that tars from cigarette smoke do indeed cause cancer. So medical authorities do not hesitate to say that smoking causes lung cancer. The US Surgeon General states that cigarette smoking is, quote, the largest avoidable cause of death and disability in the United States. Conducting an experiment in which some subjects were forced to smoke and others were not allowed to would be unethical. And in cases like this, observational studies are our best source of reliable information. So the most complex issue of data ethics arises when we collect data from people. And here are some basic standards of data ethics that must be obeyed by all studies that gather data from human subjects, both observational studies and experiments. Okay, so number one, all planned studies must be reviewed in advance by what's called an institutional review board, charged with protecting the safety and well-being of the subjects. All right, there has to be some type of administration of the experiment that is ensuring the safety and well-being of the subjects that are being studied. Number two, all individuals who are subjects in a study must give their consent before data are collected. Okay, there are cases in the history of this country, terrible thing, where people were deliberately involved in an experiment without their knowledge or consent. Okay, which is a major breach of ethical standards. And also, individual data must be kept confidential. Only statistical summaries for groups of subjects may be made public. and there must be enough subjects so that confidentiality must be maintained. Okay, if we were to do an experiment or an observational study on the school, and there's only 2 or 3 people that are in one certain category, then we would probably not be, it would be a violation of ethical norms to publish that data, because some people could infer from the results of that study, and therefore confidentiality would be breached. Okay, so people got to give their consent. Results must be confidential, okay, when it comes to individual data. And there must be some type of control. Normally it's this institutional review board that's in charge of making sure that everything is safe and protecting the subjects. Yes.
Are there also ethics for like animal studies?
I believe that there are. Okay, but I'm not very familiar with that off the top of my head. But that could be something that you could look up there. But yes, I believe that there are. Yes.
What if like smokers gave consent to like Volkswagen? Couldn't they just do like that?
Yes, I mean, but that's still an observational study, okay? Because that's where they gather this information, right? If you're trying to gather information about does smoking cause lung cancer, then you're going to look at longtime smokers. And so the people that are participating, that choose to participate, must give their consent to do that. You can't just go collect data or information from people without their knowledge or consent. That would be a breach of ethical norms. Okay, I am going to stop there.